am really thankful to Mr. Mohol for accepting our invitation and being amongst us today. As you already know, Mr. Mohol is the Managing Director of StruEngineers Private Limited India. He has around 20 plus years experience in precast projects. He also specializes in Nordic precast projects. If you know the Nordic countries, basically I think he's referring to Sweden, Norway, all these countries. Then he has also handled project management on various precast projects. In the last 7-8 years, he has also been handling precast building information modeling or BIM software called Impact, which is a product of StruSoft. So thanks again, Mr. Mohol, for accepting our invitation. It's really a pleasure to have you amongst us. So the floor is yours, sir.
Thank you, Mr. Kushal. And once again, thank you all for joining. And I think it's very good initiative by your university to speak to various expertise in these fields. That's a presentation I'm showing. So this is about precast construction, and then there is a second line called cost-effective and time-saving way of construction, because there is always a question. You have seen the in situ structures or cast in place structures where we are pouring beams and columns and on site. And then what is difference between precast and cast in situ? So as the name suggests, it's precast, so it is already casted in a controlled environment, and it's cost effective. There is a myth that it is expensive, but it is not. There are ways to do it more cost effective and time saving, since we can save 40 to 50% of time. So imagine you have to build a building with, let's say, G+10 structure, and if it takes around 1.5 years to 2 years with all the possible project management and micro planning, still precast can do it in 6 to 8 months time frame. I'll just talk about StruEngineers. We are a company located at different locations. We have like 35 years of experience in precast, especially when we talk about precast or history of precast. So it's been started many years ago. You see in Qutub Minar in Delhi, you see there are some precast columns and beams surprisingly being used. So this is not a new technology, so to say. It has been used many years, but not to the heavy extent in our country. But when we come to the European or American territories, they use this technology a lot. So there are various stages of the design or precast construction. So the stage one is design, where you do a lot of planning and design of a building, and then stage two goes to production, where you have a factory setup and you do a lot of production of beams, columns. So all these elements which you see on site casted together, they are casted in a fragmented way. So there would be many columns, beams, walls, slabs, and then they will be connected, assembled together on site. So that is stage two. We call it as a production, and it is much automated nowadays. So you have less labors inside factory, a control environment. And then stage three is curing. So there is a very advanced methods of curing also. Then the next stage is on-site, where you have transportation, where all these elements are shipped together, shipped one by one, whatever the erection sequence are there. Then the installation happens, and the last stage is just finishing. And believe me, finishing is very less, since the products are finished, the finish are smooth, so you don't have to do plastering, which is a big plus for precast. So why precast? When we come into the comparison mode, and why precast and why not the in situ or conventional way? So you are avoiding brickwork, you are saving a lot of steel because you are using these big span hollow core slabs. So pre-stressing is done, so you achieve big spans. and it is always a safe and better construction sites, because you are not putting up those many form or prop work and the labors and suspending from more heights and doing the construction, but you are doing it very dry and clean construction. The quality control was done very precisely inside factory in a controlled environment, and all these concrete mixes, all these pores, everything was done so meticulously, so you will see better quality. Then easy construction joints, efficient design, so you do a lot of value addition while designing. So this is a precast system for housing. So we are taking one of the example, but you can do a lot of with precast. But this will give us a big good idea about like these hollow core slabs. These are like 1.2 meter wide slabs, and you can see a longer spans of those. And these are hollow precious elements. Then there are staircase which are also precast, and then you can have exterior walls which are load bearing or not load bearing, and you can have a nice treatment, concrete treatment on those walls. And as I said, you can pre-fit those windows and doors also in the, so those elements are ready. Then internal walls, those could be non-load bearing or load bearing. So the entirely whole building or whole house is done in precast, and you are left with very less work on site. So as I said, it's very important to have a planning when you adopt such a new technology. So you need to have a good design, good architecture team who can adopt this technology. So you should have a production facility, and all these things are done with right rigorous planning. Because once the building plans layouts are freeze, once the design is freeze, then you cannot change. In conventional way, you have like a lot of modifications coming even after building, and then their walls are casted here and there, and then still there are modifications. But in precast, you have to be very sure about your planning, and it really helps to achieve the results in a faster way. So there is a case study. What I emphasize here is one of the project in Ranchi we did. So you can see two architecture layout. That is the challenge. The left architecture layout, you can see there are a lot of offsets, and which is not exactly suitable for precast technology. So what we did, that we sit up with architect and we said, see, we need to make it precast friendly, and how we can bring it, make it a box structure, and you will save a lot of money and a lot of time doing that. And we really adopted that. We made it suitable for precast. You can see we avoided a lot of corners and offsets, and this becomes very nice, easy structure. So it was like G+4. Total units were 500 number of flats or apartments, 1 and 2 BHK, and total built up area was like 500,000 square feet, 5 lakh square feet. There were slabs of 5 lakh square feet, load bearing walls were, so all structure was done by precast, using precast. So wall were like 10 lakh square feet. So it is always the double of the floor always. And then there were partitions. So total 20 lakh square feet of construction done using technology. So you can see on the right side, there's a picture coming from a factory, how these elements are lifted, casted together. Then these stairs, how these molds are placed, and how many number of stairs been done there. So total precast stairs to be produced were 200, and production capacity per year was like 600 numbers. So on daily basis, 2 flights were done. So precast factory could be on site. As I said, some of the sites are quite huge, so they don't they save time of transportation of those elements there. So they put up precast plants around the sites, and that is why they did a lot of tables there. You can see, and this was done in the open environment. So there's a possibility of doing the molds on site also. And then there is a quality lab. So there's a complete planning. So various technologies of Microsoft project and MSP and a lot of things were used, but everything was under control using this project management. So that was a organization chart. So what is the role of project manager, what would be supervisor's role, who is a crane operator, crane is very crucial, then who is handling purchase and stores and inventory, and so much detailing was done in the organization chart. And then we have used our software which is called Impact Beam. So you must have heard now this building information modeling, and that is what we are doing. We are using our software which gives project management, and we can track the elements using mobile application. So you have a complete control using mobile application. Then you can do cost estimation, resource management, and quality assurance of the whole structure, whole the elements. So this is building information modeling, where we are using software where we can do project management, we can do production planning, we can do design and detailing using single software. Let me know if you have any doubts. I would be really happy to share your doubts or address your doubts. Thank you very much.
Sir, can we make a precast beam and column, sir?
Yes, as I show you in the pictures, we can make precast beams and columns, walls, and everything using. If you see this picture, so these elements are precasted in the factory, and then they are assembled on site. Even beams are pre-stressed, so you can apply pre-stressing forces, and you have large span beams for your sites. So in industrial structures, we can get up to 20 meter spans, 22 meter spans, or more than that. So there is a possibility of using precast, pre-stressed beams and normal columns, 3-story height, 4-story height columns as well.
So then how reinforcement are connected to each other, sir?
Yeah, good question.
Also,
Good question. If I show you my slide again of the connection, I can show you one example. So this is, can you see my screen? Detail number 13.
Yes, sir. Yes,
Yeah.
sir.
So you have a cross section here. So this is a beam, a blue color beam, and you have two slabs coming from either side sitting on that beam. So you are connecting slabs with beams. But so now this blue element beam is precasted. This hollow core slab or this hollow core slab is precasted. So they are coming together on site. They are placing beam first, then putting slabs on top of the beams, and then they are putting. So with this beam, the reinforcement is sticking out, right? And then they are pouring concrete on top of it, and which is called as a structural screed. And then these three elements become as homogeneous after putting structural screed on top of it.
And sir, which IS code is fluid, sir?
Unfortunately, IS code is not meant actually for precast yet. There is a ICI, Indian Concrete Institute. They are working on these codes. So soon we'll try to follow IS code. But when these structures are happening in India, there is American code which has been referred, which is called ACI, American Concrete Institute, or PCI, precast, especially precast code is there. And there is Eurocode 2, which has been followed for these structures, which are very common now.
Sir, which type of cement precast is generally made?
Cement is normal, but the mixture, the M40, M30 grade, like if we see hollow core slab, pre-stress element, so it requires minimum M40 kind of grade. With normal concrete, it is like M30 onwards, M25 onwards. So the mixed designs are is high quality. And when I'm saying about these grouts, so those grouts are very high quality, M60, M70, because we are jointing these elements together. Yes.
Good evening, sir. Sir,
Good
this is
evening.
Aditya Parashar from final year, sir. So I wanted to ask, like, in the strengths of the precast, you have mentioned, sir, these are really seismic resistant. So like we can see this, sir, there are different parts or members we put together to make a structure.
Yes. Yes.
So what is a unique thing about the connections or the interactions between the members that make it more seismic resistant as compared to the normal construction being done?
Good question, Aditi. As I mentioned, India, New Zealand, few countries are really seismic prone, and in New Zealand also they are doing a very high rise structures, and we call it as a cumulative system of joints. So if we go to Europe, where seismic zone is very mild, so they don't follow, they just do welded connections. These elements are stitched together with welding plates. But when it comes to India or seismic zones, or in Middle East also, we put this emulative. So we emulate monolithic joints. So all these elements are put together, and the jointing will be done on site with these grouts. So that monolithic structure, that will become a monolithic, and that will become a high seismic resistant.
Okay, so sir, before doing that all monolithic grouting and all, sir, is there a vibration, a vibration factor being considered for that?
While designing, all these vibration seismic factors are considered, and when the elements are placed on site,
Yes.
they always put the temporary supports for each element
Yes.
until and unless that joint is formed, that connection is formed, and once that connection is formed, when it becomes monolithic, and then they can take out the forms or the temporary supports.
Okay, sir. Thank you, sir.
Thank you. Hi.
So my question is that as we know the initial cost of it is high, what we can do so we can make it cost so that everyone can be able to precast.
Uh, Good question, and Mohammed. Actually, it's been a question put up by many of the developers in country. Why we should adopt precast when it is expensive? But there are two ways of making it economical. One is like I showed you example where we did in this project to make the architectural layout suitable. I'm not saying on the left side layout is not suitable, but it is expensive when we have a lot of offsets around the building. So as far as you are becoming more uniform with your modular structures, when you are repeating floor number 2 to floor number 3, 3 to 4, so then it becomes economical when you have a lot of repetition. For example, you're casting like 500 wall elements of same geometry, same size. Absolutely, you are becoming more economical. And when it goes to a scale, when if you ask me, sir, can I do a precast building economically just G+4? So I would say no. You need to have large scale and a good facility to construct these, and then you become more economical. So that is why these all big builder companies, they are making it more economical by doing mass construction.
Yes, what if we increase the plants in India so that initial cost can be decreased as the competition will be high?
If I understand you correctly, the initial hurdle to set up a plant is the investment, and for that investment to happen, you need to have a lot of buildings to be done in precast. Otherwise, if you just do a plant and if you just happen to do only one building or two building, you are going to hamper. You are going to have a lot of losses. So it's always better you have long projections and you're doing a lot of precast work. So then it becomes more economical viable.
Yes, sir.
Thank you.
Sir, so
Yes.
so so this precast, sir, how can it be, sir, applied in, sir, other constructions such as bridges and roads, sir?
I really couldn't understand you. Can you repeat your question, Himmat?
Sir, he's asking how can precast be applied in bridge construction?
It has been applied already. If you see many of the bridges in Pune, now in my neighborhood, they are building this metro, and I see these bridge structure for metro. They are precasted. So it's been heavily, actually, before buildings or structures, it's been heavily used in bridges or metros. So precast has been widely used over there. So only thing is, like, you will see the pillars or columns are casted on site, but all these bridge elements are precasted. So they are using a lot nowadays precast.
Sir, what will be the overall dead weight effect on dead weight of the structure compared to
Exactly same as of your in situ structure. So if you calculate any structure dead weight, it will be same, because we are not using any different material. It will be reinforced concrete, and only difference would be this strength of concrete. Otherwise, the weight would be absolutely same.
So the foundation is done in the same way.
Yeah. The foundation can be done with precast, but most of the constructors they use normal in situ foundations. So the weight of the precast is not, actually we are saving a lot with this hollow core slabs in precast, where we are taking a lot of concrete from the web of the slab.
Sir, and sir, my another question is, sir, by which criteria we choose pre-tensioning and post-tensioning? By means in which structure we will use pre-tensioning?
Post tensioning is not been associated with precast since it is on-site work. I see a lot of now conventional structures. They do beams here and there with post tensioning, some girders, and in the bridges you will see a lot of post tensioning. But when it comes to precast, it is always pre-stress, which has been preferred. So in precast, you won't see post tensioning much.
Sir, in precast we will not see post. So, sir, but in many bridges and all that, post-tensioning is only used.
In conventional, yes, they are using post tensioning, but in precast, as I show you the hollow core slab production, you have seen how the pre-stressing is done. So hollow core slabs, double T slabs, beams, those are all pre-stressed.
And sir, my last question is seismic analysis. How we do seismic analysis in this?
The same way as we do it for the in situ structure, it has been applied in the same principle.
But
So
sir,
it is
here bars are not used. Reinforcement bars are not.
reinforcement bars are used not in only slabs, but there is a screed on top of the hollow core slabs. So if you see one of the connection, the reinforcement bars are used in the inside beam or inside columns. So there is a reinforcement. So there is nothing different than in situ. The only difference in situ and precast is, like, it is made in precast factory, and in situ is on site, poured on site. So that is the only difference. Otherwise, you will see same kind of reinforcement, same kind of rebars inside any element.
And sir, you have mentioned about many environmental facts.
Yes.
So can we, sir, replace because it is done in controlled manner? So can we replace concrete with some other material?
Other than concrete?
Yes, sir.
There are been various experiments going on, but until now, 99% is being used as a precast or concrete, so to say. But yes, there are many experiments going on with different materials. So there is this AAC block which have been used, but that is not much related to precast.
Thank you.
Thank you.
Hello, sir.
Hello.
Yes, sir. My question is that, what is the durability of this precast building as compared to the conventional building?
This has a high durability. When we design building, we always design it as a 50 years long, 100 years long. So according to that durability, when you see a good questionnaire, In situ, we see after 20 years, many of the buildings are collapsing or there's a redevelopment going on. In my locality, I see many of the 20 years, 25 years old in situ buildings are, they are rebuilding those. But in precast, in Europe, we have seen building like 50 years old, 60 years old. So there's always a good lifespan of those structures.
And sir, one more thing, sir. One more thing I want to ask.
Yes.
So, so with time, the connection between the two elements of this precast does that not affect it? Like the connection gets loosened, or we need to repair. Is it like that?
No, because these are as good as your in situ structure. So how do you connect your beams and columns in situ? By monolithic, right? So
Yes.
we are also applying monolithic way of doing the joints here. So you will hardly have any difference between these joints and versus in situ concrete joints. So you are pouring concrete there, you are placing rebars there on that with the screed and picking out rebars. So there is no difference as far as the joints are concerned.
And sir, does the retrofitting of this kind of stuff is possible?
Yes, retrofitting is possible. Yes.
Yes, sir. Thank you very much.
Thank you.
So,
Yes.
so like you said, we do. There is no difference in the in situ and this. So, but like in situ, the mixture made for the whole construction means like the mixture is made and then we do
Yes.
the
Yes.
construction and then we pour it and then it is one go process. So, but when
Yes.
when we are using precast, the structures are already made with some proportion of a mix.
Yes.
But
Yes.
when we are going to pour for the connections, we are making a mix for making the connection monolithic. So there may be a variation or there may be a change in the proportional mix. So there can be variation. So what are the considerations for that? So
Yeah, good question again. For example, if we mold or cast a hollow core with M40 grade concrete, and then when we are placing our screed on top of it to make it monolithic, so there is always a difference between two mixes. So
yes,
maybe the upper layer could be M50 or M60 or M40. So what happens that on top of these elements, when the hollow core top or the slab top, so we make it as a rough finish, or even for beams, we make it as a rough finish. So there is always a anchorage, or there is always a structural bond between a fresh layer of concrete and a settled layer of concrete. So, and again, these reinforcement which sticks out of these elements, so that also makes sure that there is a bond between two different concrete. So there has been a design process, there has been a quality process which makes it, that challenge is there, but
yes,
we have to make some adjustment on site to make it happen.
yes. Thank you.
Thank you.
Sir, in case of precast method, we require more cement, and then there will be more production of CO2. So, what would we do for to manage those things and the population?
Actually, it's a vice versa. Actually, the cement or the concrete is very, as I said, in conventional, there is always a lot of wastage, and that is where we are really struggling with in situ concrete. But in precast, we are saving a lot of concrete on first hand, and second, when we are using pre-stress element, again we are taking a lot of concrete out of the structure. So it really saves our CO2 emissions. So the concrete proportion is always lesser in case of precast than the only the quality of the concrete is on a higher side, or the strength of the concrete on the higher side. But yes, the CO2 emissions are it's been researched and developed that okay, the CO2 emissions are always been on the lower side when it is in precast or offsite construction.
Good evening, sir. Sir, my question is, what is the reason of the honeycomb in concretion?
Yes, very good question, very good point, Dilkush. Actually, that's a big issue when you see. I think you must have visited some construction sites, and there is a honeycombing issue when we are pouring concrete from the top of the column on the molds on site, and there is a honeycombing issue. And even the slabs, you can see after taking out the formwork, you will see honeycombing issue. But with precast, it has always been controlled. Has been very high quality. There's when we pour concrete inside those column molds, beam molds in factory. So there is always good compaction happening because columns are casted horizontal, and then you don't have to pour concrete from top and then having honeycomb effect. But in precast, you have very good rich surface where you can do needle vibrations, and then these tables are also vibrating, so they also play a vital role in avoiding any honeycombing and good mixture of concrete. So again, that's an added advantage with precast technology. Good point, Dilkush.
Thank you, sir.
Good evening, sir.
Good evening.
So my question is whether precast concreting can be replaced with 3D printing.
Uh, Again, technology advancement is happening, but every technology has its own limitations and pros and cons. So 3D printing is coming of technology, and but when I think of heavy load bearing structures like bridges or big industrial buildings, then I see limitation. But I'm not sure much about 3D printing. But when it comes to precast or in situ, then we have no big issues with pre-stressing elements. And then again, there's one more technology coming up where we call it as a PPVC, where all these elements, a living room or bedroom or kitchen, those are casted in factory, and then they are installed on site. So again, there's another advancement of precast is happening. So it's called 3D pod or PPVC technology. So there has been a lot of advancement happening. So we have to wait and watch and see how this 3D printing, because it's coming from different countries, China taking lead on it. But yes, these are technologies which are really coming up fast.
Thank you, sir.
Okay.
Sir,
Yeah.
can we compare it with a steel structure? About its stability and all that.
I couldn't understand your question correctly.
I think, sir, what he's referring to is steel structures are also prefabricated structures.
Yes.
So he just wants to compare your precast concrete structures and
Yes.
steel structures, prefabricated steel structures.
Steel structure has issue. Why our houses are not made of steel? Because there are some cons, and why steel is more used over factories or industrial, because there are some pros of steel. That is why concrete plays or precast plays a good role, where we have an industrial building or houses we can make out of precast. But precast has more advantage than steel. If you look at precast, then there is a good insulation. As I show you a sandwich wall where there's an insulation between two leaves of concrete, and which helps in maintaining the temperature of the structure. So in steel, you don't have that possibility because you are just structure. So people build concrete casing around steels if they want to do that. But in precast or in concrete, we can achieve that easily with our normal structure. So there are pros and cons, but I would say precast is more widely used over different kinds of structures, be it industrial, be it residential. Okay.
So I think sir has answered most of your questions, and I think he has a lot of work to do also, so we cannot keep him here for a long time. And I know that you have more questions, but I think we have to end the session. So, sir, really, we are really thankful that you could make the time out and spend it with us. Obviously, the students have found your session extremely interesting, That is why they have so many questions.